Guys, we will start in few minutes. Do let me know if you can hear me out, if the audio is all clear. And we are live on LinkedIn and YouTube as well. You can join us in any of the locations. So do let me know in the chat window if you can hear me out. Okay, so great. We'll start in few minutes. In the meantime, guys, please do let me know about your background. You can share your experience with us. You can let us know, do you already work in the data platform or with Azure, or which tools do you work with? Or if you're coming from any other cloud, if you have any specific expectation from us, we will be talking about Lakehouse Architecture today as part of the DP-203 preparation webinar. And we'll understand what is Lakehouse, how it is useful. We will start in few minutes. Please do give your introductions in the chat window. Let us know about you. Rohani, so let's get started. It's already time and we have people waiting for us. So let's get started.
Okay, Shivam. Good evening, everyone. A very happy new year to you all. I hope you had an amazing start to this year. Thanks for joining in our today's session. Before we start, let me just give you a brief introduction on Tech Scalable. Tech Scalable provides services across training and consulting domain focused on cloud, DevOps, machine learning, data science, and artificial intelligence. Today's webinar on DP-203 Azure Data Engineer Associate is presented to you by Shivam Sharma. Shivam is an author, cloud architect, speaker, and co-founder at TechScalable. Being passionate about ever-evolving technology, he works on Azure, GCP, machine learning, DevOps, and blockchain. He's also a Microsoft certified trainer. Shivam architects solutions on cloud as well on premises using a wide array of platforms technologies. Over to you, Shivam.
Thank you, Rohani. So let me quickly start my camera as well and let's get started. So good evening, everyone. Hope you are doing well. I'm pretty sure now you can hear me out. So we are live on multiple channels right now. We are live on YouTube. So in case the stream quality of LinkedIn comes down because of any reason, you can join, you can just continue on. YouTube as well. Now, I'll quickly get started. And today we are doing a webinar on DP-203, which is a data engineering certification from Microsoft. And as part of the certification track, there are multiple things which we will be talking about. And today we are focusing on the Lakehouse architecture. Now, Lakehouse is something which is pretty new. It is something which is cutting edge, which is has been recently introduced by Databricks. And Databricks are the pioneers in Lakehouse architecture. They are doing a lot of innovations right now. So we will be going through the Lakehouse. We'll understand why is it important, why we should implement Lakehouse, or why logically the world is moving towards a Lakehouse architecture. And as part of the agenda, we'll be covering. So if you want to know about some sort of new technology, you need to understand the benefits and the, you can say, any challenges which the existing data architectures are having. Because of that, the new architectures are being proposed. So we'll go through the benefits of data warehouse. We'll understand the benefits of data lakes. We'll understand what's the best about both the worlds, and what is the Lakehouse architecture. What's the main principle behind it? What are the how, what is Lakehouse? We will go through the research paper of Lakehouse as well, and we will see what are the major points which are described in the white paper. We will also understand so Lakehouse is the theoretical architecture. Now, if you have to implement it, then how do you do that? So we will talk about the Delta Lake. We will talk about the Delta Lake engine as well. And we will see how we can create a Lakehouse in Azure. And we will also align whatever we are covering with the certification. And we will see how whatever we have covered today will be a part of one of the, you can say, which will help you in getting certified as well in case you are looking for it. So we will cover one particular portion of the data platform which Microsoft Azure offers. So there are some quizzes as well, and announcements will be there. And the session will be slightly short itself. I will try to keep it within 70 to 80 minutes. We'll try to finish it in, let's say, in that time. Now, we also are giving away ebooks. We have to, and this giveaway is sponsored by Pact, and we are giving away the Azure Databricks cookbook, which will help you create the real-time analytical and the Spark-based solutions in the using Azure Databricks. So to get the ebook, there will be a quiz. I will share some link towards the end of the session. And most of the questions which will be there in the quiz are already part of the session itself. We'll talk about that. Lakehouse is something which is very new, and not many companies have implemented that. So we'll see what those challenges and things are there. And we'll also have a quiz on top of it. Apart from that, I have also added some extra questions over there, just in case you answer all of it. Then just to avoid some collisions, we'll see. And this quiz process we'll do towards the end of the session, right? So just hang in for that. Now, let's get started. So I'll do one thing. I'll just take you to my Azure Databricks notebook. And I just want to talk about the Lakehouse architecture first. We want to understand the you can say why, what, how behind it. Let me just quickly zoom in so you can see that. Okay, now let's get started. So we'll see the benefits of the existing architectures, and then we will combine the benefits, and we'll see why Lakehouse is something which is new. So if you are new to Lakehouse, then just hang in for next maybe 20-30 minutes, then this will get clear. What do I mean by Lakehouse, or what the world means by Lakehouse architecture? And in case you already know it, then that's amazing, right? So, okay, now before we learn something new, we just have to do a quick recap of the history of what we are doing today. And then once we understand what we are doing today, we will find the places where improvements can be done, and that those improvements will be done with the help of the Lakehouse architecture. So basically today, if you think from the point of view of any business, there are two types of systems which we have. We have the OLTP and the OLAP systems. The OLTP systems are running the business. They are the transactional systems which are row-oriented, and we are doing transactions with them. And then we have the OLAP systems are there, the warehouses are there, which are basically, you can say we are doing descriptive analytics with them. These systems will be column-oriented, and we will be running one ETL job, moving the data from OLTP into OLAP. And with that particular job, we will once the data is there in the warehouses, we will create reports on top of it. We will do descriptive analytics in a nutshell. So this is what we are doing today. It's a two-tier architecture. You have operational databases and operational locations, and we also have the warehouses. So 2 tiers, data is present in 2 locations. Please, that is something which is one of the core idea behind Lakehouse architecture, that in the existing architecture, we have 2-tier data model, or maybe more tiers, but we have multiple tier data model. Okay, so let's just go through recap the history first. Let's go through the background, and let's understand the benefits of what we have today, and then how Lakehouse will use those benefits. So if I cover the benefits of the warehouses which we have in the market today, we can understand that these warehouses are something which are not new. They are there since many years, and they were introduced during in 1980s. And most of the typical warehouses which we have, or most of the warehouses which we have, are based on some sort of relational SQL engine. And some of the popular data warehouses will be like dedicated SQL pool in Azure, where you can store petabytes of data, and you might have heard about the schemas which we have, the star schema, snowflake schemas, the fact table, dimension table, and this is you can say data is normalized over there and stored in some sort of data model. So the benefits of warehouses will be that they are, you can say, or if I talk about Microsoft's warehouses, we can think about that. They provide poly-based functionalities. We can run queries in multiple heterogeneous storage locations from one location itself. The modern warehouses, they provide MPP architecture. The MPP architecture basically looks like this. This is what I have, you can say, snipped from Microsoft's website. And here, if you see, we have a control node, we have compute nodes, and storage layer is there. So data, this is very similar to MapReduce. So whenever you run any query, the control node will be, you can say, breaking the query into smaller pieces, and it will run against the compute nodes, and the data will be in the storage nodes. And everything is highly scalable. The compute nodes can have up to 60 nodes over there, and you can also pause the compute in case you're not using it. And the storage nodes will be having 60 distributions. We can do partitioning, indexing, and everything is possible over there. Pretty, you can say, good solution. So MPP architecture is something which is good. It helps us in running queries on a massive scale. And just in a nutshell, there are multiple type of ways in which we organize the data over there. You can have the fact tables which we have can be hashed over there. The dimension tables can be replicated over there. And if you are loading some data, we have staging concepts. We have round robin tables, and different type of table structures are there, or different type of table options are there in which we can put our data in these warehouses. So warehouses are good. They are amazing. They do what they are doing pretty good. And on top of these warehouses, we'll do descriptive analytics. So these are the benefits of the warehouses. Now, just a quick recap into the data lake and why do we need it, and the benefits of data lake also. So in today's world, the businesses are designed, or they run, or they get benefit, or they get the competitive edge by using any analytics, or by using the data which they have, or they might want to provide more value to the customer. They want to improve the customer experience. They want to understand whether the changes which they have done is increasing the value to the customer or not. So this analytics can be done on the data which we are gathering from various sources. So in a typical data lake is available in all the clouds as such, or data lake concept is there in all the clouds as such. And in Azure, we call it as ADLS, Azure Data Lake Gen 2. Now, typically data lakes have no upper limits, and they can store any file format. File format doesn't matter. And these data lakes are built on top of very cheap object storage. So, and they are pretty high available. They can have multiple type of replication options over there. And the data which we have in the data lake can be used for your machine learning or for your analytical purpose. We can find the sentiments of the customer, whether they are happy with the changes which we have done, and is it increasing the value for the customer or not. So for that, we are gathering the data in the data lake. So data lake is that one central repository which is storing all of your data. And this is something where we can also move on-premise data, and it's one central repository. So if we think about the benefits of data lake, we will be thinking in terms of that it's a pretty cheap, durable storage location, which is very high available. It is using open standards. One of the very popular file format which we have is called as Apache Parquet, and that's one of the format in which we store data in today's data lake. And these data lakes are replacing the HDFS layer in the Hadoop or in the big data architecture. So we don't have to create, so that HDFS, the big data clusters will read from the data lake versus reading from any HDFS based storage layer. So they support the standard formats, open formats like Parquet. They store all type of data, pretty durable, no upper limit, MPP architectures. Not really MPP, but you can say we can achieve pretty high throughput from them, and we can also create our solutions with it and easy to manage as well. So in Azure we have ADLS, which is a cloud solution. It's a storage as a service solution, and works pretty well. So these are the benefits of data lakes and warehouses. Let's see the challenges which we face when we talk about warehouses and data lakes, and then we will put the Lakehouse architecture into where the improvements can be done, or what was proposed by Databricks in this particular respect. Now, if we think about the challenges of the warehouse, so these are the filtered, you can say on a very high level, all the challenges which any of the warehouse product which comes to your mind may face today. So if you think about any popular, I'm pretty sure you know some popular software as a service warehouses. If you know them, you can comment that in the chat window. Any pretty popular solutions are there. And we also have platform as a service solutions in Azure or other clouds as well. So in a very you can say filtered manner, the type of problems which they face will be that there is no support for the video and the audio or text data. So this unstructured data which we are gathering from various sources, so we can improve the experience of a customer, or we can do analytics on top of it, is not natively supported by these data warehouses. Now, we can load data. There are some solutions in Azure where you can take the machine learning solution, you can run your machine learning in the SQL database. So you take your program to the data, you don't bring your data to the program in a sense. So those are there, some of the exceptions are there, but typically we don't have any good support for data science and machine learning in today's data warehouses, which is again another problem which is seen. So they don't support real-time streaming. You will not be able to do that, or you may have to look up for any other solution which is doing a stream into the can say warehouse, and then the stream out will be again another challenge as such. So another problem which is there is all the particular warehouses, they have some sort of proprietary way of storing data. They might be pretty good, they might be pretty popular in the market, but they lock in the customer. Once you use that particular product, you particularly get logged in over there, and then you may not be able to move your data pretty easily, or you can say smoothly, and you may have to write some ETL jobs to do that. And then definitely if you write ETL jobs, you have to pay for the tool which is doing that ETL process as well for you. Now the challenges of the data lake are basically over here. Let me slightly zoom out. So I have this slide deck from Databricks, courtesy to Databricks, and I have just embedded that over here. So when we talk about the data lake problems, so the data is hard to append. And if we have existing data in the data lake, then it will be difficult to modify. If and the asset compliance is not there in data lake. So if there is any job may fail, you if half of the data is appearing in the data lake and the rest is missing as such. So apart from that, you can have you must be aware of the Lambda architecture, right? So in Lambda architecture, we have the hot path versus the cold path. We separate those paths because that was the most logical way of creating something as fast as possible and then doing some cold analytics on top of it. So now that Lambda architecture, or if we try to do the mixing between the stream job and the batch job in terms of a data lake, that becomes a problem. Inconsistencies will be there. The historical versioning of the data is costly. It is difficult to, when you are storing all the data, even the metadata about your data becomes very large, and that also becomes difficult to store. You may have a lot of files with you, and if you know that when we have a lot of small files, then it becomes a problem to run any operations against so many small files, you can say. as such. So too many file problem will be there, and it will be difficult to get a very good performance from these data lakes, and quality issues will be there. Your data might be not consistent with other systems as well. So these are the challenges which we face with data lakes. So both warehouses have their own benefits. Data lakes are also having benefits. All the companies are using them right now. So if I just put them over here, so this is where Databricks comes into picture, and Databricks predicts, or Databricks suggests that the world is logically moving towards an architecture and where we are combining the best of both the worlds. So even if we have, so the whatever the best warehouses do, that the lakehouse will be able to do that. Apart from that, we will also combine the data lake concept as well and get the best of the both world. So now I have this white paper over here. I'll just explain the Lakehouse architecture in a few seconds as such. Let me just zoom in over here. And this is the white paper of Lakehouse. And let me see if we can. Okay, so what I have done is I have highlighted few of the major points. I have also summarized that. I will give you this notebook as well for you to refer to it later on. So I have summarized these points over here, but before I go to the summary, let me just go through the major points which are proposed in this Lakehouse architecture, where we are unifying the data warehousing and the advanced analytics together and providing one platform. So I'll just zoom in a little more. So let me see. Okay. Now, there are three major deciding factors or governing factors, or you can say main principles which are there. First is that Lakehouse should be using open formats like Apache Parquet. They should not be having any proprietary way of storing data, which is not flexible enough to be, and that should not lock in the customer as such. These lakehouses should also have a world-class, you can say first-class support for the machine learning and data science workloads, which are pretty dominant today in all the domains, all the industries. So they also should offer the state-of-art performance as such. So three factors are there: direct access data format, support for multiple workloads, and state-of-art performance. These three things Lakehouse should provide. Now, a couple of extra things which are described over here. I'll just summarize it for you. And let me just put it over here. Okay, now a couple of more things which are there is that right now there is a two-tier data architecture where the data is copied two times, and all the companies, virtually all the Fortune 500 companies are using the two-tier data architecture, as it has been seen. And now the data is being moved from the data lakes or from the operational databases into the warehouses using ETL jobs. And these ETL jobs, they add their own complexity. They may fail. We have to run them, schedule them. They also introduce delay, and you have to sort of basically do those ETL jobs with another product as such, or another tool or something, maybe ADF or something, by which you have to do that. So let me just summarize. I'll go to my summary. So this is the white paper from Databricks itself, and you can just look up in any of your search, you can say any of your favorite search browsers, and you can find this. Now, if I just summarize all these points, I have the summary here. So the key features of Lakehouse is that it should support multiple data formats. It should be reliable, should be consistent. We should have asset compliance over there. It should support diverse workload. BI functionalities, data science, machine learning, analytical functionality should be there. The BI tool should be able to directly access the data from the data source as well. All of these major points are described in the white paper. Now, the two-tier architecture which is being used right now, which is dominant in the industry right now, is it creates two copies of the data, and user pay double the storage cost. And this is something which Lakehouse can simplify. Okay, so that's one of the major points, that we are keeping our data copies multiple times. So can we do something over there or not? Now, some other challenges which are there. This is something important. So what are the challenges which we are facing right now in the data architectures. So the two-tier architecture is complex. We have to maintain it. We have to create that. The ETL jobs will move the data from operational databases into the warehouses, and these ETL jobs themselves will create complexity. They will create delay, failure. You will wait for the ETL job to execute, and then you will be able to do your descriptive analytics on top of the data. Otherwise, you can read from the source itself. So the inconsistencies will be there. You may have different versions of the data in different databases or in different data locations. You may have heard about the changing dimension, slowly or fast changing dimension. Those type of problems definitely will happen. So if they happen, then you have to make sure that you are sort of doing you are making sure that the differences are handled by some sort of technique over there. So ETL will currently in today's world, ETL is you can say creating failures and it is introducing bugs. Now, another thing from the point of view of business is that we are storing the data multiple times. In the two-tier data architecture, we are storing data once in the you can say source location, and then it is also you can say being moved into the warehouses. So the customers, this is somewhere we can also make a change. Now, data lock should not happen. It should not be, the format should not be proprietary. It should be open formats like Parquet should be used, or any other new format which anyone. Okay. Now, Lakehouse is something which is being, you can say, researched on right now, and new formats are being created, and it is encouraged that the community will come up with new formats which can help in unifying the two-tier architecture into some sort of unified architecture. So it is not something which is like which may have all the answers today, but this is something which is the cutting edge, or you can say Lakehouse is something on the cutting edge of the technology or on the data in the data platform, and it's possible that new formats, even more optimized than Parquet, might have to be created for in future for this to be more you can say widely adopted, right? So it's a research field. Things are going on. Okay, now check this out. So I'll just show you what do I mean by Lakehouse architecture. So typically what we want is, okay, so this is where, so in a sense, this is where we have, so what we want to provide is that we should not have a two-tier architecture. The data should be in data lake. And then on top of it, we should be able to have some sort of asset compliance layer, which can provide the structure. And on top of that, we should be able to run the queries, and we should also have some sort of capabilities of doing caching, like we can do that in the warehouse solutions today. So what Databricks proposes is that we can create Lakehouse architectures which unify the different diverse workload requirement by adding whatever we have in the green over here. So if I just walk you through that, so on the bottom, we have the data lake. And on top of the data lake, if we can put a metadata caching and indexing layer as such, then what this layer will help us in what it will help us in, we can say in achieving, will be that location which can support BI reports, data science, machine learning, and so on and so forth. So the correct architecture is, or you can say the detailed one is over here. So let's have a look at that. So this is what Databricks has offered, and you can access Databricks in any of the cloud platforms. It's available in Azure, AWS, and other platforms as well. So if you see, so this is the Lakehouse architecture from Databricks, and this is achieved by using two layers over here. We have a concept called as Delta Lake, and on top of that, we have the Delta engine as such. And on the bottom, we have the data lakes as such, which you can see is somewhere where I'm moving the cursor right now. So the Delta Lake is already open source by Databricks. It's already, you can say most of the companies are already using it. And the Delta engine is something which is like a secret sauce of Databricks. It's available with a Databricks solution. So what Delta Lake provides, it provides a structured transactional layer on top of the data lake. But just by having a structure on the data doesn't mean you can achieve the same performance with which other solutions are providing in today's world. For example, warehouses have capabilities of having some sort of local caching functionalities. So this is where Databricks brings in the Delta engine, which will be a high performance query engine, which will combine various methods by which the caching can be done. We can provide query optimization, and they have released a concept called a thing called as their native query execution engine called as Photon. It is available in Azure. You can have a look at that. And the Lakehouse architecture can be realized by using Delta Lake and Delta Engine. So what is this Delta Lake? What is the Delta Engine? This is something which we will be focusing on, you can say, in more depth today. And check this out. So if you have any questions, please put your questions in the chat window. I'll just, the chat is open in my secondary screen, and I will be able to, I'll just take your questions on the way as such. Okay, so have a look at this. So the Delta Lake is basically, so we were just talking about the Lambda architecture, where we are creating two different path for as such, hot path and the cold path. And we were handling the streaming requirements, and we were handling the batch requirements as well with the help of Lambda architecture. Now the Delta so what Delta Lake does, Delta Lake provides the capability to create a table, and you can run the streaming jobs and the batch jobs against those tables at the same point in time. So it is asset compliance. It will make sure that your data remains consistent. It is designed to work with Apache Spark, and the customers today are creating. So the customers who already have started using Delta Lake concepts, what they are doing, they are creating three different type of tables. They call them bronze, silver, and gold table. Now this is like a theoretical concept. So in what we do in bronze tables are the raw data which is getting ingested from various sources. Those sources might be on premise. Those sources might be like a Kafka stream which is coming in, or any other location as well. Those bronze tables, the raw data comes in the bronze table. The silver table, another type of tables are there in the Delta Lake, which are called as silver tables, and this is where we have the filtered, clean, augmented data. And this data might be created from the bronze table, and or maybe using some another table or another source where you have enriched your data and you are storing it in a query, in a table where you can do a query. And then we have gold tables, where silver tables, or you can say various columns in the silver tables, might be aggregated together, and to create the data or the tables from where you can create the BI reports, and you can aggregate everything together. So the three type of tables are over here, and I'll show you this in few minutes. How do we create that basically? So right. Okay, so check this out. Now so Delta Lake is basically already open sourced. Everybody is using it, and in case your company is not using it, then you will logically move into it in few years. The secret sauce behind the Lakehouse, the realization of the Lakehouse architecture from Databricks, is their Delta engine. See, just by adding some sort of layer on top of the data lake is just not sufficient enough. The query should run fast enough, and it's a persistent layer. It's something which will persist as such. So data technically stays in data lake, but you can say the Delta Lake tables are created on the same data on top of data lake, but it is persistent. It doesn't need your cluster to be always running, right? It's not like a view. It's persistent. So now, so what is this Delta engine? So what they have done, this is the high level architecture of Delta engine. It has three things: query optimization, Photon is the native execution engine, and the caching layer is there, where SSDs are used to cache your data as such. Now, what we do is, the Delta engine basically, it will do file management, you can say optimization. So we can do caching as such, which is something which is, you can say, pretty useful and done by all the different products. There is a thing called as data skipping as such, which is here referred as dynamic file pruning. It's already available. And query execution, which is more effective, is also done. What Photon does, so what they have done is, they have created this native execution engine called as Photon. It does data level parallelism and instruction level parallelisms. So data level parallelism means that with the same instruction, you can process multiple data points, and instruction level parallelism means that you can say process multiple instructions at the same point in time. So this increases the performance a lot, right? There are some statistics available on Databricks website. You can just look up for this, and I have not put them in this slide right now. Okay, now basically, if I just summarize all of it again, if we think from the point of view of Azure, we may be using Event Hub or IoT Hub or Kafka clusters to ingest the data, or data might be coming from on-premise using Data Factory. Delta Lake provides multiple ways by which we can load data into these tables. We have autoloader, we have copy into ADF copies also there, so that the different type of tables can be created over here, bronze, silver, gold, and Delta Engine is the layer on top of it, which is optimizing the queries further. So let's go through the syntax. Let's go through the code as such. And before I just show you this, I also want to quickly find. Okay, so the major objective which we have today is that we are looking towards moving, getting certified in DP-203, or DP-203 in a nutshell is the data engineering certification from Microsoft, and this is something which covers anything and everything which data engineers will face today, right? Like that. So what it does, if I just show you the outline of the certification, is this is the landing page over here. And if I just scroll down to the module, so the outline is basically broken into 11 modules over there. Now, whatever we have discussed today, whatever we have covered today, or whatever we will cover by the end of the session today, is basically part of this module number 1 point over there. So yeah, there are a lot of things to we can say. If you are planning of getting certified in Azure on data platform, there are multiple things which we should know, and definitely whatever we have talked about till now is one of the things over there. So what else we need to cover, right? So in Azure, we have Synapse Analytics. That's something which needs to be talked about. And Databricks, definitely. Data Lake Storage, you need to know that. You need to know how to work with the data streams which are coming from various solutions. If you have heard about EDA, exploratory data analytics, then how do you do that in, you can say, in Azure on the raw data which is lying in the data lake? How do you run queries on top of it directly? That is what we have over here in one of the modules of DP-203. So, which is called as the Synapse Serverless SQL pool. That is something which we need to know for clearing the certification. How do you integrate with Azure Active Directory, RBAC, Active, or you can say authentication, authorization, both needs to be understood to clear the certification, or to be able to work with, or to be able to practically work on the data platform in Azure. Azure AD needs to be there, or you should have an understanding of Azure AD. Now, what DP-203 also expect you to know is how to work with the data frames inside Azure Databricks. How do you read write from the data frames using Databricks? How can you transform your data? How do you load your data into the warehouses using Apache Spark? How do you do some sort of, if you're not using Apache Spark, then how can you load your data using maybe ADF copy or Polybase? And what are these concepts as such? If you must have heard about ETL, ELT before. So this is that service which does that. And another thing which is there in the data engineering certification is how do you transform your data with Data Factory and Synapse pipeline? How do you orchestrate the movement of data? How do you create a slowly changing dimension? How do you handle the you can say late arrival of the dimensions? What is the meaning of star schema, snowflake schema, dimension table, fact tables? All of those things are something which needs to be known by the professional who wants to work in the data platform in the Azure cloud. End-to-end security from the point of view of data. So how do you do the dynamic data masking, row level encryption, column level encryptions? How do you use key vault, little bit of networking, firewalls, the credential management over there? How do you do the auditing of your data? And if you combine the OLTP and OLAP together, there is a new concept called as HTAP. Not really new, but this concept was not there in Azure. So, but it is now there. With the help of a Cosmos DB, we create HTAP systems, which is also part of the certification. So Cosmos DB is a semi-structured database, and we combine that with the Spark cluster, which is inside Synapse, and then we create the HTAP system. So that is another thing which needs to be covered. So how do you work with Stream Analytics? And once you work with Stream Analytics, what is this Event Hub? It's basically a PaaS solution built on top of Kafka. So how does the stream, you can say, what is structured streaming? How is Event Hub streaming data inside Databricks data frame, or how are we creating those jobs over there? How are we starting it? How, and anything around that is also part of DP-203. Now, what I have done over here is, if I'll give you the link to the file which I'm showing right now, but I have given this link over here. If you open it up, it will take you to the official repository from Microsoft where all the official tutorials are there from them. So this is the landing page as such, and you can also definitely you can say go through these tutorials yourself. And there are around 17, and a little bit of machine learning is also there in DP-203, around 5%, right? You should know how to, you can say, connect Azure machine learning service with the data platform solution. How can you work with both of them at the same point in time? So that is also there. So these 17 scenarios are there, which are covered over here. And what I'm showing you today is part of the module number 1. And if I just click on it, I have actually copied a part of it. It takes time to cover the entire thing. So what I have done is I have copied a part of this particular module over here. So it will definitely help you in realizing, you can say, or making progress towards the 203 certification. So what we are doing right now is, check this out. Let me open my whiteboard, and I will zoom in into the, I'll extend the screen. Okay, so what we are doing right now is we basically will be creating the, you can say, a part of the Lakehouse architecture in Azure, where we create the structured transactional layer over there. And the scenario which I'm showing you is that where we are creating multiple tables. And if I just make those boxes over here, so give me a second. So your data might be coming from any location, right? You may be using Kafka and so on and so forth. So all of those things are also technically possible. But right now, what we are doing is we will have around 36 files will be there, which will be in a disk location, local disk location to the cluster. And these files basically are in JSON format, and they have around 5,000, you can say, data points inside the files. So 36 files are there, and 5,000 data points in each files. And this is the local disk location which we are using. Now, apart, if we don't use it, if what happens if my data is coming from Event Hub or Kafka or IoT Hub, everything is possible, right? Technically, we can do that. So in future, you may have to go into those things as well, like this. So what we will be doing is we will create the bronze tables. Now, these bronze tables will be the one from where, so whatever data we are ingesting, right? Right now, like this, in your scenario, might be coming from other locations as well. So we want to ingest the data into the bronze table. And then once we have those bronze tables over there, we will do some, you can say, cleaning of data. We'll do enrichment of data, and we will create silver tables and then gold tables on top of it. So we will create bronze tables. Now, whenever you create these bronze tables in Delta Lake, you have to specify the path where the files will be stored or where the data will be stored. And this path typically is the same path of inside your ADLS or inside your data lake. So you don't have to create, it doesn't double copies anything. It just stores the data inside data lake only. So let me just put some headers over here. This is Delta Lake. Right. So we will be creating one bronze table, and in the bronze table, we'll specify the path. And whenever you work with the Delta Lake tables, we also do checkpoints over there. So for example, if I'm streaming my data inside inside a table, then if I don't do a checkpoint, then I don't know till where I have done the movement of data till yesterday and from where I have to move my data today. So we have to specify a checkpoint path as well. for the bronze table. And the similar thing, we will be doing it for the other tables. We'll create another silver table like this. We will specify the path and the checkpoint path over there. And we will also create another gold table after that, where we are aggregating the silver table data together into another, you can say, in a format on top of it, which we can do reporting. So here we will create some basic reports on top of it like this. So this is what I'm showing you right now. And if I just take few minutes to complete this, we have to do all of this. So this is the silver tables over here, and we also call them query tables. And these are the gold tables, right? So we'll specify the path and the checkpoint path as well, like where the checkpoint will be created. So let's go back and have a look at that. So the very first thing is, check this out. So I'll give you this file, but basically you have to run this setup file in the starting, because if you can see that we need some data to actually get started with. So how are we getting the data over there? So this setup file will load the data from another repository over there, so you can learn the Delta Lake concepts as such. And once you become an expert, you can use your own custom locations to ingest your data from, right? Those you can learn in future sessions, or maybe you can learn on your own as well. Now, so basically we are running the setup of the scenario. And once that is executed, this is where we are specifying the bronze table, the path where the bronze table will be created, the checkpoint path, the silver table, the checkpoint path of the silver table, and the gold table is called as grouped count, and the checkpoint path of that, like where the checkpoints will be created. So the paths are defined first. I have embedded few more slides over here for you to go through, and we'll just carry on for now. The data which we are using is basically it's a cell phone accelerometer data, where we have XYZ data points. And I'll just try to zoom in over here. Okay, so the data which we are using will be having XYZ coordinates, which is coming from a mobile device of the user, and it is having geographical location and what is the ground truth as such. What is the particular, like, is the user right now walking, sitting, standing, and maybe with this data you want to calculate how much you can say how much calorie is already burned, and what is the and if you keep on using the same pattern, or we know, right, Fitbit bands are there, and we have Apple watches. So that type of scenario where we are getting all the data from the mobile device, and then we are calculating or finding some sort of, you can say, we are doing some analysis on top of it. So we have index, arrival time, creation time, and the coordinates, user, model, device, some sort of the activities done by the customer, GT over there, the truth as such, and the geographic locations. So now we are creating a stream job right now. As we were talking about that from the Delta Lakes, you can create a stream and batch job at the same point in time. So it supports running stream jobs and batch jobs simultaneously on the same table, and it doesn't go inconsistent, right? So that is something useful. So we are defining the schema for it first. We are getting the data from somewhere. We have defined that the schema will have arrival time, creation index, and city, country, and so on and so forth. And this schema will be used by us in all the required locations wherever we want to put that. Now, if I just go further, you can see this. We were already discussing that we have, in this scenario, we are talking about around 36 files, which are having 5,000 records inside those files over there, and we want to load that into a you can say bronze table. So if I just take you back to my notebook over here, so the very first thing which we are doing is we are reading the data from the source. So the setup script which we have executed has copied some data in this path over here. Now what we are doing, we are creating one, we are reading the data from there. We are specifying Spark read stream. It's in JSON, the files are JSON. And the schema, we have just defined the schema. We are defining the max file per trigger parameter. This is something which will have a default limit of 1000. And this is something by which you can control how many files will be read or how much data is getting loaded in the micro batches over there. So it's a pretty small number right now, 1, but based on your you can say requirement, you can change that. So now the notation is pretty simple of how to create a delta lake table and how to work with it. Basically, we have to specify the format like delta, the checkpoint path, and do we want to do what type of operation do we want to do? Like it's whether is it an append operation or is it like a complete operation? Append operation will be like if I'm getting data increment in you can say in an incremental manner, then I want to append my table over there. However, if I want to aggregate my data, then the complete mode will also make sense, because now maybe I have more you can say data points and you want to find the mean, mode, median maybe, and you need to do the job on the entire column or using multiple columns. So complete mode will do it not in append manner but in a full manner. So this is the general notation of how we do that. So append and complete is there. So append only adds new records to the output sync, and complete basically you can say rewrite the full output. So checkpoint needs to be defined. Checkpoint location is there. We have already defined it. Now, if we just proceed further, so this is where we are writing the stream in the delta format, and we are creating the bronze table over there, and the output mode is append mode as such. Now, the raw data got ingested into the bronze table. Now, what we have is, it's not in the diagram yet, but there is another Parquet file in this scenario where we have the country codes with us, right? So what we want to do is, using the data which is in the bronze table and using the country codes which we have, we want to run a job over there, and whatever is the output of the job is what we want to load inside the silver tables. So now once we have these silver tables, we can run some queries on top of it. So we are doing an enrichment of our data with another file which is coming from another location as such, or another source of a stream might be there, or another local file might be there, which we are doing. So the file in this scenario is basically already available, and we are calling it as like a lookup table, and it's a Parquet file, format Parquet. It's already you can say available to us, or it is already provided to us by the setup script over there, and we are getting the country code, the codes, the countries, and that information from the Parquet file. Now what we are doing is, we are using the data from the bronze table and the Parquet file, and we are loading that into the silver table. So if I just show that particular script to you, so basically we are reading the data from the bronze table, and then we are finding, we are taking the creation time, device, index, model, user, the coordinates of the user, the geographic location of the user, and we are doing a join on the other data frame which we have made from the Parquet file, and we are using the country codes from there, the country information, and we are doing a left join on top of the data. Now, whatever output is getting, or whatever is the output of this particular query over here, is what we are inserting inside the silver tables. So I think the job is still running. It's a continuous job. I may not have stopped it. So it is continuously trying to do that. And same notation is there. Write stream delta, checkpoint location silver, append mode, and then the silver path is there. So there are multiple files which are, if we want to list the files in the silver path, there will be different files over there. Now, if the last thing which I just want to show you over here is that we are also right now doing an aggregation on the data which is there in the silver table, and that aggregated output is what we are putting in the gold table over there. So that part is over here, where we are doing an aggregation on the three attributes which we have are the ground truth right now, whether the customer is you can say moving, what is the customer doing, walking, sitting, standing, running, what's the acceleration of that mobile device, and so on and so forth. All that type of analytics can be done. You can even think about like if you get this data set, you can think about multiple machine learning scenarios on top of it. Like what further value can you give to your customers. How can you improve their experience, maybe detect the any critical medical conditions as well, and so on and so forth. So after doing the aggregation on the data, we are putting the output into the gold tables over there, and the job is still running. And this is where we are sort of, you can say, we can run queries on top of it. This is my final data over here, which is aggregated with the help of silver tables, and on top of it, we can create reports. So you can connect with Power BI. We have multiple methods as such. I just have a simple, you can say, you can create some custom plots inside the Databricks notebook as well, which we are doing. Now, what we have covered is like a batch stream job. You can also do batch jobs. You can further do optimization on the files and many more things. So what I have done is I have already embedded all the links for you. So if you go through the links over here, you will be able to do that as well post the session. So you can cover all these things and way more advanced things on top of it. So this is what you can say, basically wanted to cover for the session today. I wanted to focus on the cutting edge Lakehouse architecture and want to introduce the architecture to you and want to relate that to the DP-203 certification. And please go ahead with your questions. In case you have any doubts and so on and so forth, feel free to ask. And I will just quickly do some announcements in the meantime. Okay, so check this out. So a few announcements as well. So the we are actually are a training and consulting company. We also provide our own trainings, and in case anyone is interested in whatever we have discussed today, and if anyone is interested in learning, you can say other things as well, way more concepts than what we have covered today, then we also do instructor-led trainings, and these trainings are over the weekends. DP-203 batch is starting from 15th Jan. It's a 5-weekend batch itself. We are Microsoft official partners. We provide their official curriculums. We provide the infrastructure where you can play with, or where you can do the scenarios, case studies, group discussions, whiteboard design patterns, and so on and so forth. We provide the practice test and post-training support as well for your, so just to help you in getting the certification and leverage that in your resume. Now, I will just look for the questions in the chat window. Please ask your questions, or I'll also quickly put the quiz in the chat. So if you can see, I have just pasted one quiz link. It will be active for many hours. I have not scheduled it to be, I have not put any limit over there, but I'll just paste it again in the chat. I think it didn't got pasted. So the quiz will also have questions about okay, so let me quickly paste that. Okay, great. So you can check out that the link is there in the chat window. So whatever we have discussed, I have put all those things in a quiz over here, and other questions are also there, which are relevant for the DP-203 certification and for your self-evaluation as well. So this link will be valid for next multiple hours. You can give your first name, last name. So we reach out to participants or the quiz winners over email or LinkedIn chat. So make sure you provide your information over there. Otherwise, we won't be able to reach back to you. So there are multiple questions over here. Whenever you get time, you can answer these questions. And we will be announcing the winners of the quiz in next few days as such. So take your time, do that. And if you have any questions, you can reach out to us over these links as well. And any question, I can see there are some comments regarding the charges of the training and so on and so forth. So Riaz, we will take those questions offline and we will get back to you. We'll reach out to you for your with that information. Okay, so regarding the notebook and the uh, and other information which I have shown you today, I'll do one thing. I will put them in GitHub and I will put the I'll paste the link in on the event page, right? So if you give me some time, you will find the details or the notebook details on the event page on LinkedIn. You can find it from there. So I'll share those information with you. Okay. So if you have any question, let me know. Okay, I'm doing another session on GitHub Actions on Saturday itself. If you want to join me to understand how to create a CI/CD pipeline with GitHub Actions, and if you want to know more about GitHub Actions, you can join me there. And if you want, the links are available in my LinkedIn profile, and there is a session on transformers as well on Sunday. So transformers are from the point of view of machine learning. We'll create some transformers doing NLP, computer vision task. So in case you're interested in that, then you can join me on Sunday. And the links are again available in my profile. So if you go to my post on my LinkedIn profile, then you will find those details somewhere in that, right? I will also be posting the links again in next few days. Okay, so there's a question in the chat saying, technically, we are replicating 3 copies of data for maintaining asset properties on data lake. Now, so I'll answer that. The 3 copies, I think, which you're talking about is the LRS, right? You're talking about the locally retained copy, or because what we have done right now is we are not making 3 copies right now. These are the 3 different type of tables over there. Like we have raw data, we have you can say data on which we can do queries, and the gold data is more aggregated data. So instead of using the data lakes where the raw data was stored and then moving a subset of the data into a warehouse where the reporting was done, we are eliminating that 2-tier architecture and the delay of the ETL jobs, and we are unifying everything into a new architecture where Delta Lake and Delta Engine are unifying them. So it's not 3 copies to provide asset compliance. This is more from the point of view of the unification of various things over there, right? There is another concept in Azure where we create 3 copies. It's called as locally redundant storage. It's basically Microsoft's way of making sure that if something goes wrong at the backend, they don't lose your data. We have LRS, ZRS, GRS, and so on. So for 3 copies, 4 copies, 6 copies. So that is different, right? This is not that. Okay, right? Okay, so silver, bronze, gold tables are not because of providing asset compliance. Asset compliance is there. Also, if you only have bronze table, no problem. That will also be having asset compliant. It is provided by the Delta Lake layer, which will do the structured transactional layer on top of the data lake. That was more from the point of view of requirement. Raw, query tables, and gold tables aggregated. Okay, then uh, If you have any other questions, then please go ahead with that. Or you can also find me on LinkedIn. You can uh, post your questions directly to me. And if you can also drop us an email on the sales email ID and or on the contact number. I'll just paste the contact number again in the chat window. The trainings which we do, so we actually looking at the professionals who are already working, we provide the trainings over weekends as such. And we have 4 hour session. The session starts at 7:30 and will finish at 11:30 every weekend, Saturday and Sunday itself. So 4 hours on weekends, and the sessions they different trainings have different stretch of the sessions, and DP-203 will be stretching for 5 weekends as such. Okay, then then that's all, guys. The quiz link is going in the chat again. Please give your attempt the quiz over there, and we will be announcing the quiz winners in few days. And I'll find you in the next sessions. Rohani, if you want to add something, please go ahead.
Yeah, so thanks Shivam for today's session, and anybody who wants to contact us can contact on this number 9717972309 or email us at sales@techscalable.com.
Thanks, everyone. We'll wind up, and you can find me on the on any of the platforms for any follow-up questions. Right? Thank you, everyone. Thanks for joining in.